So we are continuing to look at inferential statistics and what tests are appropriate when and what do they tell us. In our last video, we compared to a value. We looked at nominal, ordinal, interval, and ratio when we're comparing to a set number. We did our one sample t-test to see if the average number of people in our union, the average number of years that people have been at the business was 5. We looked at whether or not the median response to a Likert scale survey was 4, and we compared the number of people from the 3 different locations to either equally distributed, a third, or a pre-existing number. We assumed half were at one particular location. So we compared to values in our previous video. Now let's look at what if we're looking at not one group, but we're looking at 2 groups. And so in this case, what we're going to be doing is we're looking at, are those 2 groups different people or are they the same people? In this video, we're going to assume there are different people in the groups, in which case we're going to see, do these 2 different groups have different opinions, categorize themselves differently, and so on. So if we have 2 groups, we have different people in the groups, then following our chart here, if it is nominal data, we will do a Fisher's test. If it is ordinal data, we're going to do a Mann Whitney. And if it is ratio or interval data, and we can assume a normal distribution, we're going to do a 2 sample t-test. If we can't assume a normal distribution, that is, there's a central number, and then as you get further and further away, the likelihood is less and less, then we will go back to down our measurement scale to how we would treat an ordinal and use the Mann Whitney test. So if your distribution is not normal or is unknown, we go with the Mann Whitney. So let's take a look at how we would do these tests. So we are working in the Inferential Statistics workbook. You can find this at drstephpowers.github.io/BIA. Inferential Statistics is the workbook. Go to GitHub, go into Google Colab, sign into your Google account, save a copy so you can edit it. And we are using data sets here. So we are going to be using what we call DF2. That is the coded bargaining data set that we have talked about in previous videos. So make sure you mount your drive and you import your Excel files. So here we're using bargaining numeric and the CRM clean. All right, so let's dig in. Let's start with the Fisher test. So when we're doing these tests, we're looking at the difference between 2 groups, and these are different people in the 2 groups. The way the Fisher test works is that we have our data here, and we can simply enter in the information. We don't actually have to pull it from anywhere. And so we're going to need the Fisher exact, and we're going to need NumPy as NP in order to build the array of data. So when we're doing our Fisher test, we first import our package, and then we have our information here. So with a Fisher's test, what we have is that we have 2 groups, group 1 and group 2. And with a Fisher's test, we're assuming that they fall into 2 categories. Okay, so let's think of our categories as yes, no. One group that answered the question 19 and 16, and one group that answered the question 7 and 6. But let's just see where this information came from. So I'm just going to add, let's import from, let's see, we used import from pandas, import crosstab. So let's use what we did before. From pandas, import crosstab. Okay, so remember in our previous video we did a pivot table or crosstab table, and then what we can do is we can look at, we can create a crosstab here that is question 2 and question 5. So question 2 in the survey was part-time and full-time, and question 5 in the survey, we just go back to the survey here, was, do you believe that your pay is similar to the same position at another organization? Yes, no. So if we go in and I just pull this, what you see here is that the part-timers, one person said yes, 7 people said no, 7 people said I don't know. For the full-timers, 16 people said yes, 19 people said no, 8 people said we don't know. When you're doing a Fisher's test uses a 2-by-2 table, which means we're going to have to drop the I don't know group and simply look at the yes, no for is the pay equal to other organizations. And here we have 2 groups, the part-time and full-time. So we can actually just type this in here. So we can say, if you want, you can say, here's the no for the full-time, here's the yes for the full-time, here's the no for the part-time, here's the no for the full-time. You could put it in another order if you want, 16, 19, 6, 7. If that makes you feel a little better, you can do it that way. It's up to you. But it really has to just be a 2-by-2 table where within the hard brackets, that's one group. So that's the full-time here. And then within the next brackets is the part-time. So if we load that in, then we run the Fisher's exact. The Fisher's exact is that 2-by-2 table here. And then the alternate can be less than, greater than, or two-sided. So when we're doing a two-sided test, we're simply saying difference or no difference. That is there a difference between the groups in whether they think yes or no that the this case, the question was, is your pay similar to other organizations? So the distribution here between yes and no, is it different for part-time than it is for full-time? That's what you're testing here. Is there a difference in the 2 groups in how they answered this binary question? So we had to convert this into a yes, no. And that's because Fisher has to be 2-by-2. Two groups, 2 options. Okay, so let's go back in. Not that one. We don't need that anymore. Let's run our Fisher's exact. And so with the two-sided, it's just, is there a difference? No difference. Very large p-value. Okay, so what that is saying is that there is no difference. We can't detect a difference either because the sample size is too small or because there's truly no difference. We cannot detect the difference between group 1 and group 2. And it makes sense because if you look at this here, part-time, it's about the same number of people who say, yes, we're paid the same, no, we're paid differently. With the full-time, notice there's not really a difference between those who said yes and no. So it makes sense that we would potentially the null hypothesis that they are the same. We cannot go with that there's a difference. And because of, you can see the small sample size and the numbers are fairly close to each other. Okay, so what it looks like is that there's really no difference in opinion between the part-time and the full-time. If the p-value was small, then we are saying there is a difference. So for most of these tests, if you have a small p-value, there is a difference. If there is a large p-value, there is no difference, is the general interpretation here. What if the counts are not known? So here, right, we had our groups. In this case, let's look at question 5. And instead of specifying them out like we did here, we could pull the information. So that's what this is doing here. So rather than typing it out, 19, 16, 7, 6, what we can do is we can actually just pull it from the data. So we have the same packages because we're doing the exact same thing. We just want to make sure those packages are loaded. And what we're going to do is we're going to pull out just the information from the table 2, that is the coded table. And we're going to pull from the coded table from question 5 the responses that are not equal to 3. So remember, we looked at our introduction to Python coding. This exclamation mark in front of the equals means not equals. So what we're doing is we're removing this category 3 here. That's the I don't know. Okay, because again, Fisher's, we have to have a 2-by-2. So if we do this, we create this new value df2 underscore q5, and we can look at it what it looks like, df2 underscore q5. what we've done is we have taken the data and we have the same table we had before, but what we've done is we've removed from Q5 all the 3s. So you no longer see any 3s in that Q5. So we've created this new table that has Q5 without the 3s in it. The reason we're not pulling out just Q5 is because, remember, we want to look at Q5 broken down by the answer to Q2, part-time or full-time. So we want to maintain the integrity of the full data set. We simply want to remove from the data set any place where Q5 was equal to 3. So that's what we're doing right there. All right, so let me get past this giant table. Okay, so then what we're going to do here is we can show it in a crosstab, and that's what I pulled for you previously. So let's just show that, df2, fe, based on the crosstab. So notice here, once we remove those 3s, I've created this 2x2 table of question 5 and question 2 that have, so here's question 2, part-time, full-time, and then the answer 1 and 2, which if we go back to the survey, 1 is yes, 2 is no. Okay, so then we can do the Fisher exact, same as before. This time though, instead of having to provide it the numbers, which is what you saw up here, we wrote 19 and 16 and 7 and 6. Instead, we're just pulling directly from the data set. In order to do that, we had to create a crosstab that didn't have this third option in it. So if I go back, Fisher's exact, df2 underscore fe, that's this crosstab that doesn't have that third column. And then we're still checking an alternative of two-sided, which is there a difference in opinion between part-time and full-time in a question that only has 2 options? Fisher's requires only 2 options. And what we see here, we get that same p-value of 1.0. We're not detecting a difference. These are about the same. Those are about the same given our sample size. So either there is no difference or we can't detect it. Okay. All right, so we have just done, where are we? We have gone through and done our different people in our groups, Fisher's test. Now we have the Mann Whitney and the 2-sample t-test. To do a Mann Whitney, we are going to need to import something called Mann Whitney U from skippy.stats. Okay. And we then need to identify, so question 22 is the one we're looking at here in this example. So let's go to question 22. Question 22, do you consider yourself to be part of an underrepresented group? So we have people who classify themselves as underrepresented and those who don't. We also have a preferred not to answer. Because this method is only for 2 groups, we need to create a group that's a yes group and a group that is the no group. Okay, so that's our first step in our process, is to say, okay, let's create, we'll call it df2 q22a, and it is going to be the subset of question 22 that is only group 1. Okay, 1 and 3. What do we have here? Yes, no, prefer not to answer. All right. So I think when I created this, I'm trying to figure, what was I testing? What we want to know is ultimately, is there a difference in their opinion? And here, question 20. Question 20 says, my workplace is inclusive. So our thought as we're looking at this is we could look at, how do people feel who are underrepresented groups? Do they feel that it's inclusive? And no, they're not part of an underrepresented group. Do they feel that it's inclusive? So we could run the test and we could run 1 and 2. Okay, so let's start with there. Let's run that. So here is group 1. That's the ones who said that they are part of an underrepresented group. Yes. Then we can look at those who say, I'm not part of an underrepresented group. We'll call them 2. Notice that the way this is done, this is the full database is maintained. It's not just pulling out the variable, we're pulling out the full database and creating two databases. So let me just show you what that looks like. DF2, question 22A. You'll notice this is a full database, but what it does is for question 22, it's only the ones. So we're creating two separate databases here. This one is only where question 22 is a 1. And then if we look at B, right now it's only where they are 2s. Okay? So we create two separate data tables, data frames. One where they answered question 22 is yes, one where they answered question 22 as no. So then when you do your test, you do a Mann Whitney U, and then we call from question 22A, that's the one table, we want question 20, and then from table 22B, we want question 20. So that way what we're doing is we're saying, okay, this question 20 about workplace is inclusive, we want to know if there's a difference based on 22. So we basically have to separate these out into our two groups here, excuse me. All right, so we run this test. Notice this p-value here is 0.16. So we're thinking maybe there's no difference between those who are part of an underrepresented group and those who are not part of an underrepresented group in terms of saying whether something is inclusive. Okay. Well, if you've done surveys related to equity, diversity, and inclusion in the past, what you might know is that the people who won't tell you whether they're part of an underrepresented group, those are the ones who feel it's not safe to disclose that they're part of an underrepresented group. And so when it comes to a question about whether the place is inclusive, likely those who are afraid to report what they are, it's because they don't feel included. So we're not going to see a difference here between yes and no. We're going to see a difference between those who prefer not to answer and those who say, for example, say no. So what if we change this? What if we run a test here where we compare where did I go here? We could do a comparison here between, say, group no and group I don't want to answer. Okay. So we could do this, just cleaning this up here so we can see at a glance. So I could compare the not part of an underrepresented group and the I don't want to tell you. And with that change, when I run the test, we can see now there is a difference. So those who are who are not willing to disclose whether or not they're part of an underrepresented group have a very different opinion about inclusiveness than those who say they are not part of the underrepresented group. You could also compare those who declare they are part of a represented group and those who decline to answer, which I think is probably what I had originally in this data set, and you can see a difference here. So the difference is really those who are afraid to disclose whether they are part of an underrepresented group, they're the ones who don't feel included. And so maybe they're afraid to disclose because they don't feel included. So we need to look at whether or not it's a safe place to disclose whether you're part of an underrepresented group. So with the Mann Whitney, what we have is two groups. Here, this is those who said they are part of the underrepresented group, and here are the ones they won't disclose. Here, they're not part of an underrepresented group, and here's the not disclose. And then we have another question where we're looking at the difference in response. And a Mann Whitney uses an ordinal question. So the question 20 that we're comparing is this workplace is inclusive, a Likert scale. Okay. All right. So we have done a Fisher's test for the nominal data, which was yes, no, you feel like you get paid the same as others. And then an ordinal, how do you feel about inclusivity? So again, two groups, but the question that we're comparing here is this was Likert, this was yes, no, nominal, paid the same or not. Here, if we have ratio or interval data, we use a 2-sample t-test if we can assume normality. So let's go and look at that 2-sample t-test. So let's go back to the only ratio question we have in this data set, which, or I guess we have two. So this is the years that we've been here at the company. And here, let's compare question 4A. So let's go back and see what 4A was. So 4A, wellness account. So the question is do people care differently about a wellness account if they've been here longer or not? Okay, so 4A. Now 4A is the actual, all these multiple choice. So it's not just wellness account, but health spending account, dental, drug. So perhaps those who've been here longer, they're good with most of the benefits and that's why they stayed. So maybe they just want top-ups, wellness, health spending account. Maybe people who haven't been here longer, they have greater benefit needs. We're concerned they might not stick around. Okay, so let's see if there is a difference. Now, in order to do these two groups, what we have to do is pick two categories. So we can only have two groups. So what we're going to do is we're going to take 1 and 6. Drug coverage is going to be one group and wellness account is going to be the other. So we're going to look at those people who prioritize wellness and those people who prioritize drug coverage. Is there a difference in how long they've been at the organization? So we start off by creating two tables. One table where question 4A is equal to 1. That's the wellness account. And one table that's question 4A equal to 6, that's the people who want more drug coverage. So we're going to create two tables, and then we're going to compare those two tables based on question 24. That's the interval ratio. This is the years they've been there. So from Skippy.stats, we need t-test independent. Independent because these are two groups that are not the same people. Those who prioritized wellness accounts, those who prioritized drug coverage. Then we do our test. We compare the table that had those who prioritize wellness, and from that we pull question 24. And then we have the table that prioritized drug coverage, and we're pulling the results of question 24. So we run our test here. We get a p-value of 0.0738. So if we're doing our alpha of 0.05, then we don't see a difference. It could be a sample size issue that there's not enough people in these two categories to detect a difference. But we cannot declare that there is a difference in their ages. If this p-value is less than our 0.05, we would say that those who want drug coverage are a different age than those who want wellness. This here, because we're not specifying a direction, is assumed to be a two-tailed test. Either you are the same or you're different. We're not assuming a direction, greater than or less than. You could add a direction to it, same way we did with our one sample test. Alternative equals, two-sided, alternative equals greater, alternative equals less. Those are your options there for the tails. Here, we're not detecting a difference. You could have a different alpha. We could be using an alpha of 0.1, assuming a 10% error given a smaller sample size, in which case maybe there is a difference here. So ahead of time, you choose the acceptable alpha before you start seeing p-values. If this is a very large database, then of course our alpha would be 0.01 or 0.001, in which case no difference.